Good morning to everyone, and welcome to another session on TCS Digital Training by Quant Masters. This is Shashank here. I'll be your technical trainer today for our live training session on TCS Digital, where we will look at the recent trends which are often asked in interviews. And when we talk about recent trends, we know that there are a lot of things like machine learning, artificial intelligence, and deep learning, which are often asked because when TCS hire, they have this one concept that is they often ask questions on recent trends, whether you are from CS background or not. So, knowing that they do ask this, it's basically essential for us to know a little about it. So, in our session right now, we're going to look at these four parts of recent trends, and we're going to see what sort of questions can often be asked within it and how do we answer them. So when you begin with all these terms, there's one term that is synonymous with everything. That is, they generally ask up like, what do you know about data science, or what is data science according to you? Yes, as one of you also pointed out, there is also Internet of Things, there is blockchain, and there is cloud computing, and so on. But in our first session here, we'll be focusing on these four. We do have another session later on from 6 p.m. today, where we'll be focusing on the rest as well. So one of the first question you can expect is, what do you know about data science? So here's the thing. Data science is pretty much performing something on data. In short, I'm not stating this as the exact definition, this is in short, but if you want to try to explain and answer to them like what exactly is data science, we need to understand something before this. See guys, everything when it comes down to data science, it's a combination of three streams, and unless we know all the three streams, we can't learn this whatsoever. I'll just point out what exactly these three streams are. Take this for instance. um, let's say you have computer science knowledge, that is basically your coding. Let's say it could be Python or anything, because that is basically what we use to perform machine learning or deep learning, anything we generally use Python. So followed by this you need mathematics, that is particularly statistical knowledge. If you don't know statistics, then again I'll state that we can't work through data science or machine learning. Followed by these two, the third thing we need to know is domain knowledge. So entire concept of machine learning or data science, whatever it could be, is a combination of all of these three. And let me first explain what exactly each one, or how exactly each one is a part of it. Think about this. You have, let's say, you're working in an insurance company where you have data of, let us assume, 100,000 customers, and you want to figure out who will or will not um, be benefited by insurance, or who will or will not be the right client for insurance. So or in other words, you have 1 lakh customer data, and you want to figure out who will or will not be the right client to buy a car. So once you get to know a new customer data, you will compare with these customer data and figure out whether the new customer will or will not buy a car. So the basic idea of data science is, you collect data, you process it, that is to make it in the right form, you analyze it, and the result, the goal. What do you know about data science? To answer that, data science is where we collect huge amount of data, we process it, analyze it using many scientific methods. And why exactly do we do that? The reason is the most important part of data science, and the reason is to predict and enhance businesses. Basically, the major purpose of data science is to predict, which is usually done for business purposes. This is the reason. So, when we talk about data science in short, the first couple of things you guys need to know is, in interviews, you're going to be asked, okay, so you know what data science is. So, what are the programming languages we use in data science, or what are the different um, platforms you're going to use when it comes to data science? So there are four major platforms or four major programming languages, whatever you want to call, when you start working with data science. Those are Python, R, SAS or SAS as some call it, and Weka. So these are the four most commonly used tools or platforms to work through through data science, machine learning, and so on. And most commonly, everyone uses Python. That is the most common one. Now, it's not like one is better than the other. If you're good at one thing, you can do the same task that is done by the other tool as well. That's the basic idea we should know. So, for now, just remember, if you are getting a question on this, for now to answer, data science is just collecting data, analyzing it using some scientific methods, particularly to predict. Now, when they ask you an example for this, I'm going to go ahead and give you guys a really nice example that we go through. But before that, since we're going to be focusing on Python, I'm going to be providing some live execution here with Google. So, for those who are new to this, Google has its own online runtime to execute Python with all the libraries required for machine learning. So there are no machine learning libraries that you have to like install, implement, or anything like that. So you basically have everything done here. All data science libraries that you require are all pre-installed. You just have to write the code, run it. It'll all be running in the cloud itself. So this is something that I would suggest if you guys don't have something like Python with Anaconda to install a lot of packages and try these out. That is one suggestion according to me. Now, to go ahead, once you get a small and simple question as to what exactly is data science, the next question that comes up generally when we talk about this particular domain is, what is machine learning? What do you know about it? And the second question that comes up is, how does it differ from regular programming that you do? How does it differ from your procedure oriented programming that you do? So these are some things that we need to understand and know. So let us try this out. Let us try learning exactly what it is. So one of the common things that we know is, in any programming language or in when you develop any program, what's the first thing that we do? We figure out what is the input, we figure out what calculations we need to do, and we figure out what is the output. So if there is something like find whether a number is prime number or not, you get an input like let's say 31, and you calculate whether it's a prime number or not. Then you given an output saying either yes, it is a prime number, or no, it is not a prime number. This is basically what we do. But here's what happens when it comes down to machine learning. In machine learning, it's the very opposite. Initially, you get the output, you perform calculation to receive input. That sounds exactly opposite of what we do. So let me help understand this. So think about this, guys. Take for an instance, in a regular program or whatever it could be. Now, again, if you guys have questions or doubts within this, feel free to text within the chat and let me know. I will respond and answer to the same, because since it's a new domain, I'm sure that there could be a few questions on your mind. So feel free to ask. So in this, think about this. Let's say there's a little kid who doesn't know the differences between lions and tigers. Now, this is the best example I can take up for us to understand what is machine learning. With this example, you will be able to answer interview questions directly. So why this analogy is required, it's hugely important. So please observe this very carefully. So think that there's a kid who doesn't know the difference between lions and tigers. So what you do is you take 100 images of lions and tigers. And okay, I have a question. What is NLP? Yes, I will be answering that particularly as well ahead. Since we are in the basic questions of ML, you will expect what do you know about NLP? What do you know about CNN? Some questions you definitely will expect. I will go through those questions ahead today as well, not to worry. So let's say you have 100 images of lions and tigers. What are you going to do here is you're going to divide this 100 images as 80 images to teach the kid and 20 images to test the kid. So in this case, exactly what happens is first 80 images, you're going to show them to the kid, saying that this is the input and this is the output. For this image, it's a lion. For this image, it's a tiger. You start explaining this with the first 80 images. After explaining with the first 80 images, the next 20 images, whatever you have, you give them to the kid and you ask the kid to predict. This is the keyword I'm using, please note very well. To predict whether it's a lion or a tiger. So this is what we are doing here. So initially we gave 80 images with the output as well. Remember, we gave 80 images with the output as well, that is stating that whether it is a lion or a tiger to the kid. So the kid will know and understand this logic. Do we do this in a regular prime number program? Do we give some prime numbers to our program, like see 31 is a prime or 29 is a prime? Do we state that these are prime numbers? Similarly, do we then give a new number like let's say 7 and ask our program to check whether it's a prime or not? No, we don't do that. We don't give output like this beforehand. But in machine learning, you give input and output beforehand, and then you ask the kid here. I'll convert these to the machine learning terms, the jargons that we use. I'll convert it to that so that you can answer with the machine learning jargons ahead, because we don't want to answer like this when it comes down to interviews. So here, the input that you're giving here is 80 images with output, that is whether it is lion or tiger. So this data is generally called training data. And the 20 images where you're asking the kid to predict whether it is a lion or tiger is called testing data. And here's the thing, for training data, you're giving the input, that is the image, as well as output, that is whether it's a lion or a tiger. But for testing data, you're only giving the input, you're not giving output at all. So output, you're asking the kid here to predict. So that's the basic difference between training and testing data, and we generally train and test in this way. So I have a couple of questions before I go ahead with this. That is, I am not exactly sure at OLU. I think you need to check the mail completely to get to know. I have a couple of other questions. That is, Will they ask from advanced data structures like trees and graphs? Generally, yes. We have covered it in one of our previous videos. You can definitely go through it for sure. And I do have another question asking, um, I am from ECE. Can I expect any core questions for digital interviews? See, you can, but it's very rare. I'll repeat, there can be core questions asked, but it's very, very rare as well. So that is one thing we just need to know. So anyway, let's go ahead back here. So going ahead here, students, please observe this very clearly. So the training data is where you're giving the input and the output for it to learn. Once it learns, you're giving another image, asking the kid to guess what will be the output. So this, we call it as training data, we call it as testing data, that is done. And what is this kid representing? What analogy is this kid representing? This kid is the machine learning model that we create. We always use the word model because algorithms are already inbuilt. Based on these algorithms, we just create our own machine learning model which can understand these kind of images and predict such images accordingly. So these are the basic terms we need to know to begin with. So machine learning is where, if you want to go with the exact definition of it, you can state something similar to this, where you have input. I can see, okay, no other questions. All right. So back to this machine learning, I'll repeat. In short, you can just state that it is where you're giving the input to any model as data as well as output. You're giving some previous data and you're asking in the program to predict another output based on only the input. So this is the basic idea of machine learning. So now that we got to know that machine learning is where you have an ML model where you divide um, the data into training, I'll just write it in short, and testing data. And the model, I'll repeat this, this is the important part if you want to explain in the interview. The model learns, I'll repeat, learns by experience. Here the person learned by the experience of 80 training images. Same way the model learns by the experience of those 80 training images. Without those 80 training images, it cannot take the rest 20 images and predict by thinking about those 80 images whether it's a lion or a tiger. So knowing this is hugely important. Machine learning model is something that you develop for a particular case. I'm developing it for distinguishing between lions and tigers. So that is my machine learning model. If you want to distinguish between cats and dogs, you need to create another machine learning model. So that's the basic difference. So we divide the data into training and testing within it, where model learns by experience. This is the major thing you have to explain and state over there. Now, how does it differ from regular programming? I think we were able to understand even this in our question earlier, or even this in our topic earlier when we did this. That is, when it comes to regular programming, you do not feed input and outputs. There is previous inputs and outputs to the model. But in machine learning, you do basically. That's the whole difference. Now, going about this, let's look at one different case scenario, not just this, so that we can understand this even better. Guys, observe this. You guys know you guys get spam in your mails. So you guys get a lot of spams, but they don't end up in inbox. They end up in a different folder called spam. Very rarely something from spam ends up in inbox, like once a month, just one mail or something. Very rarely. So how does your mail get to know what is spam and what is not? So this is also a machine learning example. Think about this. You have a machine learning model. Remember the kid who looks at lion and tiger images. You have a machine learning model which takes the input as spam mails and non-spam mails. We are feeding the machine learning model. We are giving the machine learning model with the input saying, I'm going to give you 1000 spam mails. I'm going to give you 1000 non-spam mails. Read it, understand it, analyze it, remember how they are. Then I'm going to give you one mail, one new mail. I want you to figure out whether that mail is spam or not. So this is the basic kind of idea which we need to learn and know on machine learning models. They will also ask you questions like what are the algorithms available in machine learning, which one do you use in which case, which is your favorite algorithm. These are certain questions that are asked as well. I'll try to focus on those questions as well up ahead. But before going to that, observe this, guys. Let me ask you one thing. Instead of 100 and 100, if I just give 10 spam mails and 10 non-spam mails, will it be easily able to identify a new mail? In these 10 spam mails, all of them are like, I am a Nigerian prince and I have all my account money frozen. I need you to help me access my account again, which costs $50,000. If you are giving me $50,000, I will give you back once I get all the money as $100,000. This is the kind of all the mails that are there in spam. When a new mail comes up, which machine learning model does not know whether it's spam or not, if the new mail is of a different kind than this spam, if the new mail says that instead of I'm a Nigerian prince, if it says I'm a prince from Rajasthan, let's say, and instead of dollars and everything, it has some rupees stuck or something like that. If the words everything are basically different, then it won't be able to identify whether it's spam or not spam. It will be confused. It will not be sure whether it's not spam or not spam. So it will give by some percentage confidence that it could either be spam or could not be spam. Now the reason it can't identify is because the number of data we have given is less. If we need to understand this more clearly, take the example of lion and tiger itself. If I give just 10 images of lion and tiger and I'm giving another image of a lion but from a different angle, than what is already there in these images, then the kid or the machine learning model will not be able to identify whether it's a lion or not. So this basic concept is often asked in interviews as what is overfitting and underfitting of data. This is a hugely common question. So when you talk about what is overfitting and underfitting of data, underfitting is where your training data is not enough to perform prediction, or we also call it as classification. So your training data is not enough. You don't have enough training data to easily perform and calculate whether this lion image is actually a lion or a tiger. So when the images are too less, we basically call it as underfitting. Now when the images are too much, when there are so many images that when the machine learning model starts to look at it and understand it, the machine learning model starts getting confused, and it gets confused in such a way that it looks at all parts of these images and it is now confused which feature is of lion, which feature is of tiger, with so much data. And when a new image is given, there's so much features to compare with, it doesn't even get to know whether this lion, which is clearly known as a lion, is lion or a tiger. It doesn't know. So this is called overfitting of data. Overfitting is where your training data is large, but you've divided it into so many features. Some of these features may overlap. I'll just point this out, and you may not predict accurately. So the point we need to know here is, when you talk about underfitting, know that when you have very less images, you can't predict. When you have overfitting, it could be due to other factors. Think about this, guys. I have 10,000 lion images. In all 10,000 lion images, the background is blue. It's a sky. In all 10,000 tiger images, the background, there is no background. Let's say instead of blue, the background is dark. Let's say it is late at night. So when I give one more image of a tiger with blue background, our machine learning model may get confused because it knows that every blue background image is basically a lion, and every dark background image is basically a tiger. This it knows because of all the 10,000 images, one thing common is blue background. Of all the 10,000 images, one thing common is dark background. So when a tiger photo is given with a blue background, it thinks and remembers that there is a particular feature, that is the background being blue. So it doesn't even look at the rest of the data. It just sees that the background is blue and it says that it's a lion by default. So that should not happen, and that is called overfitting of data. When you consider or take up more features than you have, that basic idea is called overfitting of data. So this is one little thing we should know, and I hope this helps easily answer these couple of questions stating what exactly is underfitting and what exactly is overfitting of data as well. Now, with this, now that we know these basic answers for the questions that they can ask, so we basically know what is machine learning and what exactly is underfitting or overfitting. Now, one of the next very common question that is asked is, what is the difference between machine learning, deep learning, and artificial intelligence? So when you talk about machine learning, deep learning, and artificial intelligence, all sound somewhat similar to begin with. So when we look at this in short, let me just point this out. When we basically look at this, what we need to know is each of these is a part of the other. I'll just repeat, each of these is a part of the other. So I'll just take, let's say, 3 ellipses here so that we can easily understand. Perfect. So the biggest part is your artificial intelligence or AI. Machine learning is a part of artificial intelligence, and deep learning is a part of machine learning. This is how we are supposed to understand this. Now, how exactly? Yes, I do have a question like, what is supervised learning and everything? Yes, that is also a very common question you may ask. There are so many questions in this domain that you can expect, because this is, I personally feel, this is the most um, asked domain when it comes down to recent trends, and you can expect a lot of questions particularly in this, so we need to know how to answer them. So just remember, for now, ML is a subset or a part of AI, and deep learning is a subset of ML. But what exactly is deep learning? What exactly is machine learning? What exactly is artificial intelligence? This is what we need to learn and understand to begin with. This is the major thing we need to begin with. So I'm going to give you guys the very perfect definition here, as Nvidia stated. I guess you guys know Nvidia because of their graphics cards and everything, and they're into artificial intelligence hugely. That's one of the companies. So here's what they had stated long time ago. See, guys, artificial intelligence basically is just the part where you are trying to, I'll repeat this, artificial intelligence is where a computer or an artificial intelligence, that's basically a computer, does the job that a real person can do. Basically, artificial intelligence is where a computer does the job where that a real person can do, and the person is better at doing that job than the computer. So we can easily identify mails which are spam or non-spam, but a computer cannot. Once a computer starts to do that, it has basically artificial intelligence. So every machine learning part algorithm is basically a part of artificial intelligence itself. Machine learning within it is an approach. I'll just call it as an approach towards AI. So you can have artificial intelligence through machine learning. That is, I'll repeat this, a model will learn, a model as in a trained algorithm, like the kid that we took an example of. A trained algorithm will learn from previous examples or previous instances and predict by itself. So we don't have to write extra code. We don't have to write extra code at all. We just need to give the machine learning model previous images, and we just need to give the next image for it to predict or classify which part it belongs to. That basically is machine learning. And since it is doing a task that humans do better, it is a part of artificial intelligence basically. So that's the idea. So this is, in short, as I would say, the difference between um, artificial intelligence and machine learning. As we know, machine learning is a subset of artificial intelligence. In machine learning, again, you have something that is division as supervised and unsupervised learning. These are the two divisions of machine learning when it comes down to that. Now, when we talk about deep learning or DL, it is a technique. It's not an approach. I'll call it as a technique to implement ML. So it's one of the ML techniques. So apart from how we basically divide machine learning algorithms as either supervised or unsupervised learning algorithms, we also have one part which we particularly say is something called deep learning, which involves a concept that is called neural networks. Neural networks are the basis on which deep learning was introduced. So if you think about neural networks, I'm just going to give you guys a basic idea of it so that if asked in interview, like what is the difference between ML, DL and AI, you should be easily able to answer, because this, I'll repeat, is one of the most common questions. So AI, we got to know a computer does a job that human does better at. ML is an approach towards AI. That is, using ML models, you can have an application which tries to do something humans do, but humans are better than computers. Deep learning is one of the techniques to implement AI, which uses something called neural networks. This is based on human brains. So when you talk about human brain, there are neurons which connect within human brain, transferring data and connecting from one neuron to another, and trying to solve whatever the problem that may be. Each neuron will do a little part. So same way, neural network is based on human brains, where it also consists of artificial neurons, and each neuron will basically take an input, do a job, and try to predict the output. So when neural networks are used, we basically term it as deep learning. There are many parts, many kinds of softwares and everything we can use towards neural networks, particularly things like, I'll just point this out. Particularly, we can use things like TensorFlow to implement deep learning. TensorFlow is often used through to implement deep learning, which is a hugely used library. So I'll not go in depth about TensorFlow libraries and everything within Python and so on. But for now, here's basically what I want to point out, guys. Remember, these are a few common questions that we can initially expect. Now, going ahead from these, the next kind of common questions that you can expect from this is, when it comes down to data scientists or machine learning, so on, we now know how important coding is so that we can create our machine learning models. We also know how important the entire concept of, I'll repeat, we also know, I have one question. Yes, can I give a few questions on computer vision? Yes, I'll be focusing on computer vision, NLP, all of these particularly in detail as well. Not to worry, I will make sure to do that. So I have one question. Okay, I have one question that I've missed out. Let me try answering this. I have created a chat box using Dialogflow. Okay, you have used Dialogflow. Also created some voice user interface. Can I tell these things in the interview? Yes. See, Dialogflow is where it's very easy to do that when you start learning about it. But that doesn't mean that you shouldn't tell that. It's not like you're creating particular code by yourself, but it's still a model that you're developing over there. So you can explain it. That's never a problem. You can state it. So going ahead from this, so now that we know these basic things that we need to know when it comes down to this, I just want to know from your responses in the chat, how many of you guys are familiar with Python? Just really let me know by one text, guys. How many of you guys are familiar with Python and machine learning, or are they completely new to you guys, or have you had any experience with Python and machine learning before? So let me just know by your responses. That will, of course, let me know in how much depth I should go towards this. All right. So okay, so all right, perfect. So now that I got a good response of this, since we are now able to know and understanding what is AI, ML, and DL, let us now go ahead into machine learning a little in depth, so that you guys can observe and answer questions as clearly as possible. Now, here's the thing, guys. We already got to know what is overfitting, underfitting, and so on. Now, going ahead from this, the next thing you need to know is, one question they will often ask is, which libraries do you use in order to work on machine learning or data science? Particularly, they will ask you which are the libraries you're going to use. So different libraries are used for different purposes when it comes to Python. I will be explaining it from Python perspective, not from R or anything else. So in Python, you need certain libraries for data pre-processing. You need certain libraries for machine learning, and you need certain libraries for visualization. Visualization isn't showing things in a graph on screen. So the libraries you basically need for pre-processing are NumPy, and pandas generally. NumPy is just a complete library available, or you can say in Python, it is just arrays. That's all. It is just arrays so that you can store and retrieve easily. That's the basic idea, because Python does not have arrays. Python has lists and so on. Lists take much more memory. Lists take larger amount of memory than NumPy or than arrays. That's why we basically have something called NumPy and pandas. And for machine learning, we generally use something called scikit-learn, which we have, as well as stats models, and followed by these. If you guys really want to work through deep learning, you can use keras and tensorflow. So keras is just, if you guys don't know about this, for you just to know and remember, keras is just a package or easier implementation of TensorFlow. So using Keras, it's basically TensorFlow, but packaged in a different way with some other features, so you can easily implement it. And for visualization, as one of you already stated, you have Matplotlib and you have Seaborn as well, if you are interested in going through that as well. So these are one of the couple of things that you need to know. So now when we talk ahead about it, there is just a few questions that we need to go through more within this. So let me focus on them so that you guys can get a better idea at this. So one of the first thing that you can expect is something about how do you handle missing values in machine learning. And another question you can possibly expect is how do you perform. Okay, I have one. Okay, I have a couple of questions. Let me try answering them. The first question is, what is TensorFlow? So, okay, basically to answer TensorFlow, here's the thing. It's just a library. I'll repeat. It's just a library, or you can also call it as a set of libraries, because it has so many things. And TensorFlow is developed by Google. Google is developing TensorFlow, which has so many libraries, and it is open source. You can use it. With these libraries, you can create machine learning models, that is particularly deep learning models. You can create a lot of different neural network models with this. So I have one more question. What is DIIB? So DIIB is something that's not related to this at all. It comes up in your web part. It's not related to this. I think if it's anything else, you guys can let me know. And I have, okay, now that these questions are done, okay, some of you have not received the mail. You will hopefully be receiving it soon. I hope you will be. Let's see. So let's look at a couple of these questions which can often be asked. How do you handle missing values? How do you perform machine learning on images? How do you perform machine learning on texts? These are a couple of questions which we often expect. So let's just look at what the answers could be for these. So guys, please observe this. When you talk about handling missing values, how to handle missing values in machine learning particularly. See, you may have something like, I'm just going to give this for an instance. Please observe this very clearly, guys, because if you answer these questions using a professional example, using a real life professional example, I think you will be impressing them much more than just explaining the same in just words. When it comes to recent trends and everything, don't just go for definition. Don't think that me defining it is going to be great. So if you can express to them that you know and understand it, irrespective of whether you know the exact definition or not, that matters even more. So let us look at this. For instance, here, let's say, the question was, how do you handle missing values? Let's say there's an Excel file where you have things like some age and something like joining date and something like salary. So somewhere a joining date is missing, somewhere age is missing. If it is missing, you can either remove that entire row. You can remove the entire row so that you don't have to use it. Or second way to make sure that instead of removing the entire row, just make sure that since you don't know the age of only this row and you need this row of data as well, take the average of all the others and put it here. Joining date you don't know, take the average of all the others and put it here. So like that, you can handle missing values in different ways. So there are three ways that you can handle missing values generally. In one, you can ignore that row of data, but if there are too many rows of such data, they are important, you need them, then in that case you can either take median to be replaced in that missing value, that is average, or instead of median, you can also take up one more thing, that is mode, which is most frequently occurred value, to basically be replaced in that missing value. So these are some things that you guys can expect. So going ahead with this, let's look at the next thing. How do you perform machine learning on images? This is a common question. And how do you perform machine learning on texts? Followed by this, for us to understand this, before this, let us go for something else. There is, what is supervised learning? This is a hugely important question, I feel, because I have seen this commonly asked many times. What is supervised learning and what is unsupervised learning? And it's not just what are they don't ask definitions. Their questions will be application oriented. Their question will be, when do I, or how do I choose if I should use supervised or unsupervised learning? This is a common question that you guys can expect as well. So let us look at this. Let us try to understand what exactly are supervised and unsupervised learning and get a better idea of it. So think about this, guys. I'll give you guys one example to begin with. Okay, one of you have had this question asked already in Ninja interview. All right, so it's a very common question. So that's why I want to make sure that we are going through all these common questions that you can expect. So here's the thing. Think about this. You have images of lion, tiger, and let me add one more animal. Let's say cheetah, for instance. You have, let's say, 1,000 or 1 lakh images of all of these, and within this you have data like certain image is lion, certain image is of tiger, certain image is of cheetah. You know that already. That is there with the training data. The output is also there. When the output is also there, you have the image along with the information whether the image is of lion, tiger, or cheetah, and then you're getting a new image and you want to predict or you want to guess whether this new image is of lion, tiger, or cheetah. What you basically do here is take this, since you already have the data as well as the output, you compare this image by the, there is machine learning model knows all of these images. These are, let's say, is our training data. I'll repeat, these are assume, we already know what training data is. These are assume is our training data. We put it into machine learning model. Machine learning model knows which is lion, which is tiger, which is cheetah. And if a tiger image is given, it will say this is exactly tiger. Now, this is supervised learning where you're taking a new image and you're classifying. I'll repeat this word. You are classifying whether this image belongs to lion, tiger, or cheetah category. Which category out of these three does this image belong to? That is what you're basically classifying to. Now, on the other hand, when you talk about unsupervised learning, observe this clearly, students. When you talk about unsupervised learning, the difference that comes up here is that in input, you don't know whether this is lion, tiger, or cheetah. You don't know at all. So you have set of images. You have 1,000 images or something. It's mixed between lion images, tiger images, and cheetah images. You don't know which of them is lion images, which of them is tiger images, and which of them is cheetah images. In that case, since you don't know them, the best you can do is look at all of these images, figure out which of them are common, which of them have some common features. All lions have some common features, so you can say that is one category. All tigers have certain common features, you can say that is one category. And all cheetahs have certain features, you can say that is another category. So you can divide it into three categories like this, because you don't know which is lion, tiger, or cheetah. You are not classifying, you are just grouping based on certain amount of data. You have input data, there's no final output, that is which is lion, which is tiger, which is cheetah. You're just grouping them. That is called unsupervised learning, where you don't have the output initially. So if you group them into two categories, lion looks differently, but tiger and cheetah look somewhat similar. So it may group tiger and cheetah into one group, lion into another group. If you group them as three, it may group lion, tiger, and cheetah into three different groups. If you may group it as four, it may try to figure out some other feature and try to divide it into four and so on. So the basic idea here is, when you talk about supervised and unsupervised learning, supervised learning is where your input training data is annotated. Now I'm coming up with a new term. I'm using a new term right now that is called annotated. So what is annotation? Annotation is where in your data you have your input image. Along with input image, you also have values, also have output, like whether it is lion or tiger, whatever is the final result. If you know the final result as well, it is basically called annotated data. This is the basic idea of it. So if it is not annotated, you can't use supervised learning because there's no output. You have to only group them. That is when unsupervised learning comes into picture. So this is where you need to know input data is annotated. You can classify a testing data into one of the input categories. Whereas in unsupervised learning, input data is not annotated. That means you just have images. You don't know whether it is lion or tiger or cheetah. If you know that there is lion, tiger, and cheetah as the output, you can say there are three outputs, or in other words, we can say there are three classes. But when you talk about this not being known, you don't know how many outputs or how many classes are there. So in that case, you can say that I don't know how many classes are there, I just have to group them automatically. So that is the basic idea of unsupervised learning. This is grouping of input data into different categories. There is no classification, it's only grouping into categories. So this is the difference. Now comes a question, how do I choose? Now comes our major interview question, how do I choose if I should use supervised or unsupervised learning? So think about this. Let's say I'll just give you guys a couple of examples, and let's say I want you guys to try figure out whether it should be in a supervised or unsupervised learning. Think about this, guys. Let me give you one example. You have data of, let's say, cricketers, or let's say cricket teams. For example, I'll take this. You have data of cricket teams, and what you're doing here is you have previous data, let's say who played against who and who won. You have the output also, who won, team 1, team 2, and who won result. Now if any two teams are given, they need to predict who's winning. Let's say, because there are many features in it, I'm not going to go into it. Let's say we just need to figure out who won. Now will I be using classification, or will I be using grouping? This grouping is also called, I'll point it out, it is also called clustering. It's also called clustering. So with this example, you guys basically know what would we use here. Of course, it's supervised. There's no doubt about it. We use supervised learning methods over here. Now, before we go on to supervised learning, before we go on to unsupervised learning, there are a lot of algorithms which do only supervised learning. Some of these algorithms are something like SVM, which stands for, you guys need to know at least the names of these. Something called support vector machines. If they ask you, what do you know about supervised learning particularly, you need to explain what it is. Since you know with an example on how to explain this, you can also give a couple of examples. There is support vector machines, there is naive Bayes algorithm, and there are many others as well. There are so many. But when you talk about unsupervised learning, think about this. Let's say I have customer data and I want to divide my customers into different categories. I don't know how many categories my customers can be divided into, like people who spend less but visit my shop more, or people who spend more but visit my shop less, or people who spend more and visit my shop more, or people who spend average and visit my shop average. So if there could be many different categories, I don't know how many categories will be there. All I know is customer data, as in customer name or customer number, which date he came up to my shop, how much did he purchase. This is all I know. I need to group this into different categories, like spend more, spend less, or spend more, visit less, whatever all these things are. So this is often solved using unsupervised learning method, that is clustering, in other words. So a lot of these things are also used in genetics. When you talk about COVID-19 analysis, so a lot of these are also used there, where they literally use RNA DNA patterns to analyze a lot of things. So it's used in many ways. So when you talk about unsupervised learning methods, there are a lot of them. There are a lot of clustering algorithms particularly that we use in our real life. Like for example, a simple thing, most common one is k-means clustering algorithm. So you're just taking all the input data and clustering them into different categories. That is your whole work. If you create 3 clusters, that means you have created 3 categories. This is basically the major difference between them. I have one more of another statement that has come up is, yes, there is also regression algorithms that is a part of supervised learning. So for those who stated regression algorithm, I will just point out, regression is used for numeric data only. Please note this. Regression is used for numeric data only. Generally, when you talk about stock market prediction, you guys have something which keeps on going. To predict what is happening up next, you basically use regression as well. So I have one question. If I can explain a bit about support vector machines and logical regression. Logistic regressions. I will see. Here's the question. I hope now you guys know how do I choose between supervised and unsupervised. If you want to classify and you have annotated data, go for supervised. If you want to create grouping of data, go for unsupervised. And you don't know how many groups should be there and so on, like the spend less spend more, that example you guys can take up. Now comes one of the most, again, common questions before we go on to images and texts. What is your favorite machine learning algorithm? Can you explain something about it? So since a couple of you have already asked, if I can give you a little bit info about SVM and logistic regression, I'll try to explain with these itself. Think about this, guys. If you have one input, I'll just take this simple example. Think about this. This is for what is your favorite ML algorithm. So the more you know about it, the more you can explain in your own words. So I have one question from one of you, that is, will past data be needed in regression? Yes, it is, because regression is supervised learning. Basically, past data is required everywhere. Your question should be, will annotation be required? I think so. In regression, annotation is required. So think about this. Let's take this very simple example. Let's say this is the age, this is the salary in a company. Let's take the example of a company. In this company, the higher the age, the more the salary. So if we draw a graph, for this age this is the salary, if age increases this will be the salary. So you take many such dots. There can be, if you keep taking everyone's example, there can be many such dots that can come up like this. So in logistic regression, in simple logistic regression, what you do here is, once you find this out, you're going to create a line in such a way that that particular line should be as close to the average. If it's too far, it's not right. If it's too far here, it's not right. It should be as close as possible to every dot. So you can say this is the average salary at that age. So once you create such a line, using the formula, you guys know the line formula, y equals mx plus c. So once you create a line using this basic formula, again I'll repeat, because of this formula, machine learning is requires at least little knowledge of mathematics. If you don't know mathematics like probability theorem, if you don't know all these basic things, it's very difficult to answer these things. So know that for machine learning you need to know basic things like probabilistic models and all that stuff. So take one equation like this. All that we are doing here is, once you create such a line, input is given some other age like 90, or let's say, let's not take it up as 90, let's say 56. We don't know the value what will be for 56. We can go to this line, figure out what will be the approximate salary, and say this is the salary for that age. Similarly, for age 27 or 30, what will be the average salary? You can go here and check it here. So such things can be done using logistic regression. Now my first question to you guys, is it supervised or unsupervised? Now that you see it, previously we had both input as well as output together, and then we are predicting for a new value, that is which value it belongs to. So what do you think? It's supervised or unsupervised, guys? Of course, it's supervised. So going ahead from this, I'll just point out, that is, when you talk about your most common or your most favorite algorithms, if you talk about something like logistic regression, then don't say just logistic regression. Logistic regression has many types within it. I'll repeat, it has many types within it. You have simple logistic regression, multiple logistic regression. You have many different types of it. So the more you go through it, the more idea you will get regarding the same as well. So it is also used for stock prediction. So you can create a line, not just a straight line. A straight line is a simple equation. If you want to create a non-straight line, which can go something like this, and you want to predict, this is not a simple straight line equation. This is more complicated. It involves more complicated mathematics. So you don't have to learn all mathematics about it, because the algorithm will be available. You just need to implement it and learn enough about it. So such logistic algorithms are also, regressions are also there. There are many such regressions, like if you look at ARIMA model and many other regression models. I'm not going to go in detail about this, because I don't think that is something we need to know huge about, but you can just note this for now. So followed by this, there's something else called SVM. This is what I would suggest. Most people say it's their favorite algorithm, because SVM is really good at what it does. There is one more algorithm that is commonly used. If you guys are interested, I'll just take a little in depth about it. That is naive Bayes algorithm. This works based on probability theory. That is, you guys have this basic probability, like if I toss a coin, it's either head or tails. That means 50% chance of it getting head. So like that, it also calculates probability of everything to figure out the output. So I'll focus on SVM. So guys, SVM stands for support vector machines. So if you're asked which is your favorite machine learning algorithm, if I am asked in an interview and I don't know deep learning and everything, my answer will be support vector machine itself. So let me try explaining what exactly it is and why exactly would I say that this is my most favorite algorithm. So let's look at this. Support, there's some sort of support. I don't know what sort of support, but there's some help, some support. Vector, vectors are lines with directions. Remember guys, vectors are lines with directions. It's a magnitude. It has direction as well. So that is basically why we call it as vector and not scalar. So it's a line with a direction. So support vector machine is a supervised learning algorithm which includes support using a couple of vectors, a couple of extra lines. So I'll just give you guys a very simple example. I'll tell you guys the two most important parts of this algorithm so that you can easily answer in the interview. And the moment you answer, they will be able to understand that yes, this person knows it well. So take this for instance. Let's say there are two classes of data. By now, I hope you guys know what class means. Class means two categories of data. Categories, or in other words, two divisions, two output values. So let's say one output value comes up something like this. This is one category. It's all here. If I draw it in the graph, it comes up here. Let's say I have one more category, which is all here. Now I'm just gonna remove this and this. All right. So if I'm supposed to divide them, all I need to do is just to draw a line between them. That's all I need to do, nothing else, because it's clear. One of them, one of the categories here, another of the categories here. So when I divide them, all I need to do is draw a line. Now the problem is, what if I draw my line too close to one class? Think about this. What if I draw my line too close to one class? If I get any data even here, it says that this data is also plus, because my division is here, my division line is here. So I'll just try to change the line color so that it's better. All right, so not this. Yeah. So if I have my line here to divide these classes, if I have one data here, since it is outside this, above this line, it says that it belongs to class plus. Or if I draw my line here, let's say something like this. If something is here also, it says it belongs to class minus. It does not belong to plus, even though it's close to here. So this is one of the problem in other algorithms. This is solved using support vector machines. Here's exactly what support vector machines does, which is the closest line towards the outside here, closest value towards the outside, that is this. So we're going to draw a line close to this, and which is the closest line towards the outside part? It's here for a minus. So we're going to draw a line even close to here. So these are the two lines that we have drawn. Now these are called, I'll repeat, these are called support vectors. So within these support vectors, you're going to draw another line which is going to be exactly between these two lines, so that there is as much distance as possible from the plus class, there's as much distance as possible from the minus class also, so that if something is close to this line plus here, you can still say it is plus. If something is close here also as plus, you can still say it is plus. If something is here minus, you can still say it's minus. So by drawing the line as close as possible in the middle using support vectors, you can say that your algorithm is more efficient. That's how its results are also better. So guys, just had to drink a little water. So with this, the basic idea you guys need to know is plus and minus. Let's say these are the two outputs. Let's say all of these are line images, all of these are tiger images. The division between them in graph is in such a way that there are two other vectors which divide those classes, so that anything which is close to another class, anything which is close to second class, is also identified easily. Think about this. To understand this with an example, take images of apples and oranges. If every red thing is an apple, if every orange thing is an orange, what if something that is close to orange, what if there is some anomaly, some picture or image problem where an apple looks more like an orange in terms of color? So in that case, you can say if this is apple class, it will look more towards here. With this support vector line, it will be able to differentiate and analyze more easily. That's the basic idea. Support vector machines, yes, margin is what you can basically state. So support vector machine basically helps you solve or classify. It helps classify when the, I'm just taking it as two classes here. When the two classes, if it is two classes, we call it as binary classification. I'll repeat. If it is more than two classes, we call it as multiple classification, or many different classes, multi-class classifier, or anything like that. But two classes, let's call it as binary. Many classes, we call it as multi-class classifier. So in binary classification, if the margin or the difference between two classes is less or blurry, it's difficult to identify which is what. So in that case, you can say that SVM helps divide them better, unlike other algorithms. So I have one question. What happens if some cases there will be present? Yes, it will be the case. In some cases, a minus can happen here also. In some cases, a plus can happen here also. No machine learning algorithm will be 100% accurate. I'm telling this straight up right away. There is no machine learning algorithm anywhere which will be 100% accurate. Most of them can go up to 95, 99 and so on. They will never be 100% accurate. So going ahead with this, what we can basically state here is, I'm not saying they will never be 100% accurate. Most of the times that's the case. So here the idea is, think about this guys. SVM does the following. And since we got to know this, we got to know how SVM is better. Now, this is not the only reason. The reason why I say choose SVM as your favorite algorithm, because you have two things to say about it. This is one reason, and the other reason is, think about this, guys. I'll just take a one dimensional value. Think about this. I have plus, plus, plus one class, minus, minus another class, plus, plus, plus second class, back to the other class. Now, can I divide them? Can I draw a line like this? No. Can I draw a line like this? No. Can I draw a line like this? No. So, no matter how you draw, it won't help out, because if you draw it here, everything on one side is one class, everything on another side is another class. If you draw it here also, these two will not be of the same class. If you draw it here also, it says all of these are of one class and all of these are of another class. So it's very difficult to classify something like this, which cannot be classified by other algorithms. I'll repeat, it cannot be classified by other algorithms either. So what SVM does is, this is where you guys need to understand this very clearly. This is why I state that you should select SVM. So what SVM does is, it converts it into from one dimensional to a two dimensional model. Two dimensional will be converted to a three dimensional model, which I won't be able to show you here. But one dimensional model will be converted to 2D model, or 2D model will be converted to 3D model. This 2D model here, this, sorry, one dimensional model will be converted to 2D model like this. We had everything in one line. It will be converted to a 2D model, let's say like this. Sorry guys, I'll just modify this. It will convert it to a 2D model. Let me put this up here and here and here. Now when this 3D model is created, now I can easily classify them with one line here. So likewise, in a 2D model, when there are mixes, in a 2D model, when you have mixes here, I'll just point it out. You have plus, 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 minus, plus, 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 minus, plus, plus, minus, minus, something like this. So here we pretty much know we can't classify it, we can't divide it in any way whatsoever. So what it does is, it creates a 3D model of all this data, and it classifies a line something like this. In 3D model, it becomes a straight line, but when the 3D is made back into 2D, it may look something like this. So like this also, it may help classify. So this is the advantage of SVM. So another advantage that it does is, SVM takes the data of n dimensions into n plus 1 dimensions to classify. So this helps it classify even in a much better way. So this is why I would say you can state SVM as your most favorite classifier, because if you're explaining this, you can basically state that you know one of the best algorithms available and you know how they work. Now let's go to one of the final questions when it comes down to this. How do you perform machine learning on images? How do you perform machine learning on texts? See guys, when you perform ML classification on images, we basically convert them to convert them from RGB to grayscale images. First step, we generally convert them to grayscale images, which is basically black and white. Different shades of gray, black, white will be there. So using this grayscale image, we generally use some algorithms like convolution neural networks. Again, this comes up into deep learning with TensorFlow. The moment we talk about neural networks, we know now that it is in deep learning with TensorFlow. We use such algorithms to solve them. So generally, most commonly used is CNN, and you basically convert RGB to grayscale to work with them. Now another one is when you perform ML on texts, texts like spam classification of your mail, SMS, or anything like that. Here we need an entirely different method, and the method we use over here is generally called TF-IDF, which stands for term frequency inverse document frequency. So this is one of the methods we use majorly, and the algorithms, when it comes down to this, you can often use all the um, basic algorithms that you have, that is SVM or anything else you can use. But one of the method we use here is called TF-IDF, and this is where NLP comes into picture. They may ask you a question like, what is NLP? What is sentiment analysis? These are a couple of questions that have been asked as well. NLP stands for natural language processing. So you guys have your Alexa, Siri, or whatever it could be, or Google Home, anything. You guys talk to it, it will understand what you're saying, it will try to respond. So all of this is because it is able to process a natural language that we speak. That is basically called natural language processing. Sorry. So natural language processing are often used to create chatbots which understand a language, and um, they try to understand a particular language and try to understand the semantics of the language, meaning of the language, and try to respond and so on. So followed by this sentiment analysis is where you guys basically, what is it and why do we use it? It's also a part of text analysis itself, where you analyze texts for their sentiments. For example, you have bought a new phone and you just go online and be like, in Amazon review or something like, this is an amazing phone, I love the camera and everything. So it will analyze that. So I have one question, what is TF-IDF? Okay, I'll explain that in detail right after this little example. I'll explain that, not to worry. So if that is a little confusing, I'll explain it. So sentiment analysis is where you analyze the mood of a text. This can also be used with voice analysis as well, but we often do this with text analysis by companies to understand how people feel about their products. So companies can't hire a person to look at each and every Amazon review and figure out what people think is good, what people think is bad about it. So that is why companies generally use such models to identify if a person types, the hotel was amazing, the service was fantastic, but the music was too loud to talk. So if this is the case, your sentiment analysis algorithms particularly will divide this. Hotel was amazing, so hotel has positive reviews. Service was fantastic, service has a positive review. Music was too loud to talk, that has a negative review. So this is how they can divide the sentiment of a person on how they felt about these things. So these are also done by election officials to get to know where they should go and prioritize more for elections and everything. Even in 2020's US elections, they pretty much use this hugely. So there's a huge usage of all of this. You can explain all of these things as well within this. Now, I have one question. So if you guys have any questions still here, you guys can feel free to ask. So I do have one question. What is TF-IDF? All right. So let me give you guys one small example very quickly, because I don't want to take a large example. So it's something that we used in a machine learning when it comes down to this. I'll just take 3 sentences. So take one sentence that is, book is good. Take another sentence, book is bad. Now, what are we going to do here is to analyze this. I'm going to create a table. I'll just explain this. I'll create a table with the word book as my index 0, is as my index 1. What other words are there? Good and bad. Good as my index 2 and bad as my index 3. So in the first sentence, book is there, is there, good is there, but the word bad is not there. In the second sentence, book is bad is there, but the word good is not there. So when you have this, you get to see book and is are common in all the sentences. So since they are frequent, since their frequency is high, since they are available in all the sentences, are they important to analyze the sentiment? No. Since their frequency is so high, they're available in almost everything, whether it's a positive sentence or a negative sentence, they are not important. So that is what inverse document frequency says. Something so frequent should not be important, and something which is not so frequent, term frequency, we calculate that. When another sentence comes up like book is fantastic, since you don't have the fantastic word in your data, in your annotated data, you can say that you don't know whether it is positive or negative, so you can just say that I don't know. So that is basically underfitting, as we learned much earlier in our session. But if another sentence comes up as good book, so you can compare this as good is there, book is there. Book is common, let's not worry about it. But good is there. It's only there in the positive sentences. So that's why I'm going to say that this sentence is positive. This is a simple example for us to understand what is term frequency and inverse document frequency for you to know. So I have one more question, that is how we implement our mechanical knowledge in IT company. Major question. See, when you talk about the mechanical, particularly, think about this. First, common thing is your problem solving ability. So whether whichever branch you're from, you know problem solving abilities. And particularly if you're from mechanical engineering, you must be at least good at Python, because basically what we expect from mechanical engineers is that you guys don't need to know every programming language, but Python is something you need to know, because you know that you will use it for automation purposes. You will need to use it because you guys already know things like um, industry 4.0, connection with IoT and everything. All of these you guys basically know. So with this, you know how important Python is. So you can just say, with at least this, I have learned Python particularly, and I am learning as of now how to implement the same with Python. That is how to use Python in mechanical engineering to perform stress-based testing or whatever it could be. So I can feel that whatever is the field, we can use programming over there if we know, I'll repeat, if we know domain knowledge plus programming, we can make it easy and automate things. If we know domain knowledge plus programming, we can make it easy to automate things. Of course, when you talk about machine learning particularly, you will need a little bit of statistics or maths as well. So that's the basic idea. So whether it's from civil or mechanical, this would be the best answer. I feel you guys know the domain knowledge, you guys know the programming a little bit, so you guys can say that with this I know how to perform um, some stress testing or whatever it is based on this. I have one question. What is web scraping? See, think about this. Okay, I did not go through Google Colab itself for you guys. If you want to go through data science everything without installing any softwares for this, you guys can use Google Colab with by logging. You need to log into your account to do this, otherwise you can't. So you can basically run any data science code within this. So if I run this, it's going to create this sample visualization graph like this, so you can perform any such things. So face color, if I make it red, it just changes to red color over here. It's still running, maybe it's taking a little time, maybe I need to refresh it, whatever it could be. You guys can try these sort of things, a lot of such modifications if you guys want. Anyway, yeah, so you guys can see some visualization like this. So I have one question. I know C language, will it be okay because I'm from civil? It's all right, but learn as much as possible. That would be my suggestion. I have one question, is Java or Python mandatory? See, here's the thing. When you're from different branches, particularly civil or mechanical, you guys state that I don't know C++ or Java, I only know C. the basic idea for the company is they are testing your ability to learn programming languages. If you at least state that you guys can um, work through the basic things like knowing C, and you at least know a little bit like basic object oriented programming in C++, and you have recently started learning programming and you're getting better at it, so anything within that you will be able to answer. If you give them that confidence and they ask you in the part that you know, then yes, that's a good thing, because they need to have the confidence that you can learn quickly programming languages, because you're going to be trained in their company for whatever they will hire you for, whether it's full stack Java development, whatever it is. That's the basic idea. This is one thing that we need to know. So with this, I'll be ending the first session of today here. We'll go ahead with the second session as well later on. I'll just copy this content for your reference. If you guys would need to go through this and access as well, I'll just share all the content typed here for your reference as well. That is recent trends session number 1. So I hope this session you guys have a better knowledge when it comes down to artificial intelligence, machine learning, deep learning, and you're able to answer these questions better. I really hope that is possible with this session. So you guys can let us know how you guys felt about this particular session, because for some of you it may have been entirely new, for some of you it may just be a revision and you are getting to know now that what sort of questions are generally asked. So with your particular feel of whatever you guys thought, you guys can feel free to respond and let me know, guys. Also, if there are any questions, please do ask. I'll make sure to answer them as well. By the time, I'll just share the link to you guys. So, all right, I do have a few responses. All right, glad to hear that. Okay, I have one question that I haven't answered. All right, that is, what is web scraping? Here's the thing, guys. Observe this clearly. When you talk about web scraping, let's say you have a website full of such data, some questions, answers, and you want to take only text part of it. You only want to extract only text part of it. Or if I'm googling something like let's say machine learning, if I'm just googling machine learning and I want to get all the links, I want to get only the link here. I want to get this link. I want to get this link. I want to get this link. I only want to get the extract the links. I don't want to extract anything else. So you can use web scraping to extract only parts of your entire web page. That is basically called web scraping. It's not just of a web page. It could be of an entire website as well, that you can scrape such data. So these are some little things that we may just need to know as well. So I have one question. I have learned AI subject from YouTube. Should I mention this? Yes, you can. You definitely can. See, it doesn't matter where you're learning it from. You can definitely mention it. If you know it well, if you can answer questions on them, then make sure you do mention them, because I feel that will definitely be useful. So thank you for joining in and staying in this session. I hope it was easy and fun for you guys to learn. I have one more question that I have just received. That is, in short term, in simple words, what is artificial neural networks? See, artificial neural networks is just an art is just neurons, like in our brain, neurons connect to each other to calculate something and transmit the data one part at a time. That is done artificially, where each neuron is a block of, or in other words, each neuron performs a task. I won't say it's a block of code. Each neuron performs a task, and it learns from the task next time what exactly should be the output in the second time. So these are the things you basically should know. So yes, I have one more question. I'll answer this as well. That is, what is reinforced learning? So I'll make sure to answer this as well. So reinforced learning, it's like this. Think about this. How do you train a horse every time, or how do you train a dog, a parrot, or anything? Every time the animal does what you're asking it to do, what do? You give treats for successful output. And you, instead of giving treats, you rectify, or instead of rectify, you say you give negative marks for unsuccessful output. So this basically is reinforced learning as well. So you give a machine learning model positive marks every time it gets an output successful, and you give the same thing negative marks every time it's not successful. So with this, it will look at the marks and understand how to answer better. So this is basically what is reinforced learning. So all right, thank you for everyone for such nice feedback. Okay, really happy to see on the very nice feedback that all other videos on YouTube on recent digital texts were either too brief or insufficient or too elaborate. I'm very happy that this was the perfect video for you all. So we'll catch up in the coming sessions as well. Have a good day, guys. Let's catch up soon. I have a question, that is, if they ask if you can, no, you, they won't be asking anything like min max alpha beta pruning, not too much. I won't expect such huge amount of questions within that to be asked. If anything, they may ask about precision, recall, F measure, which is something you may want to just look at. So all right, thanks a lot for the really nice feedback. Do like, subscribe, and follow us for more. And if you guys are interested in going through our entire um, placement training sessions, you or any of your friends, you guys can recommend them as well. So we'll end the session here. Have a good day, guys. We'll catch up in the next session. Thank you.